So hello everybody, my name is Wadim Schneider. I'm the CEO of SCC Umwelttechnik, and today I will tell you something about our technology. So the hydrothermal carbonization as a promising technology for converting wet biomass into high quality CO2 neutral biochar. Our technology center is located at the shipyard in Stralsund, Germany. And the SCC collaborates closely with Steamergy because we offer highly complementary products. At SCC, our focus is on converting wet biomass from waste, while Steamergy specializes in steam power plants, which can convert our biochar into usable energy. SCC has developed the technology to a point where it is suitable for use in the industry. And this opens up entirely new possibilities. Biomass, which was previously waste and had to be disposed of at a high cost, will become a valuable resource with high energy potential. So I will first explain what HTC actually is and how it works. I will then discuss why HTC holds incredible potential for energy supply and how companies and municipalities with high biomass waste can benefit from it. Let's begin with the topic of HTC. HTC stands for hydrothermal carbonization. Hydro refers to water, thermal to heat, and carbonization to the formation of coal. In essence, we take organic waste, biomass with a high moisture content, and place it in a reactor. You can think of it like a pressure cooker. Open the lid, introduce the biomass, close the lid. Heat it up to 200 degrees Celsius and keep it for 3 hours. At this temperature and pressure, at 20 to 30 bar, chemical reactions occur. After the carbonization, we get biochar or biocoal, processed water and some process gas. Open the lid and remove the material. The approach, similar to pressure cooker, is also called batch processing. However, batch processing is only suitable for laboratory scale. Therefore, we have developed a continuous process, and that's a milestone in HTC. Nature takes thousands of years for coal formation, but we achieve it in just a few hours. The substrate, which was previously a homogeneous mass, separates into a liquid and a solid phase. It looks like lignite in water. We have special methods to treat the process water, so it can be used for pre-flooding or reused in the industry. Our technology allows us to recycle phosphorus from the liquid phase, while the conventional approach involves incineration, the chemical extraction from the ash. We see that that method is not very effective and too complicated. Additionally, we aim to recycle nitrogen from the liquid phase to avoid the formation of nitrogen oxides during combustion, and instead introduce nitrogen as a fertilizer into the circular economy. We proceed in the same way with the heavy metals. For HTC, all kinds of waste and residual materials can be used. It is important that these are organic. The biggest advantage of HTC is, of course, with wet biomass, because it can only be dried using conventional methods with high energy input and with high energy losses. In HTC, however, dewatering occurs chemically. The remaining water is surface moisture on the coal and can be dried mechanically with subsequent air drying, or it can be burnt directly. It's essential to determine HTC parameters based on the input product. The parameters for sewage sludge, for example, will differ from those for stillage. We have, however, already conducted extensive studies. And so far, sludge from distillation processes is the best raw material for HTC due to its high carbohydrate content. Wastewater sludges are also very well suited, especially for resource recovery. At SCC, we did not invent HTC. A certain Mr. Bergius did that back in 1913. In 1931, he received the Nobel Prize in Chemistry for it. His goal was to make a contribution to humanity, but unfortunately, 2 world wars and hyperinflation hindered his research. And for a long time, HTC remained in obscurity. Until 2006, when Professor Antonietti published his work titled Magic Hole from the Pressure Cooker. HTC did not advance beyond the laboratory scale. Some companies tried to implement it, but failed. However, SCC's success in developing the first continuous reactor and building a prototype after years of research. But what's actually behind it? How does the process work? So first of all, HTC is a thermochemical process. At temperatures above 120 degrees Celsius, biomass begins to break down. Hydrolysis occurs, which is stimulated and accelerated by acids. At higher temperatures, subsequent reactions occur, dehydration and decarboxylation. During these reactions, water and CO2 are released from carbohydrates, forming acids. These acids then promote hydrolysis again, stimulating the process further. This is why it's called an autocatalytic process. Finally, polymerization occurs, resulting in the formation of biochar. Therefore, it is possible to sustain this process with very low energy input. Let's look at the carbon balance. If stillage or sewage sludge consists initially of 90% water, this water transfers almost 1-to-1 into the process water. The remaining 10%, the dry matter, undergoes carbonization. During dehydration, 18% of carbon transfers into the process water, and through decarboxylation, 7% into the process gas. 75% goes into the carbonization product. Now, the water no longer has a chemical bond with the carbon. This is a major advantage. The carbon is now highly concentrated, increasing the calorific value of the dry matter significantly compared to the original biomass. That's also why it doesn't make sense to simply mechanically dewater the biomass. The water remains enriched in the material and the carbon is too weakly concentrated, resulting in a very low calorific value. Subsequently, the coal can be mechanically dewatered, which is much more energy efficient compared to the thermal dewatering. Let's take a closer look to the heat of reaction. As I mentioned, HTC operates with minimal energy input. How is this possible? It's because some reactions are exothermic, meaning the heat is released during the chemical reactions. This might be a bit hard to imagine, but we are all familiar with examples of exothermic reactions. The most well-known is probably combustion, where a lot of heat is released, sustaining the reaction on its own. Another example is the mixing of cement with water, which heats up due to hydration. HTC operates similarly. The amount of heat released during the reaction depends on the biomass. For example, for sewage sludge, it's 0.2 megajoule per kilogram of dry matter. That's about 1% of the energy content of biochar. Only 1%. So the energy potential is therefore very large, but it's not an autothermal process. We always need to input some energy into the system. For comparison, if we want to thermally remove the water, we need more than 2 megajoule per kilogram. There's more than 10 times more energy, and we still end up with a very poor fuel or dry biomass instead of coal. Nevertheless, the HTC is a highly efficient process. So what are the benefits? No upstream dewatering required. The wet biomass can be fed directly into the reactor. No pre-treatment necessary. Biocoal is CO2 neutral, and the briquettes are easy to store. No need to transport huge amounts of water. That's one of the main advantages. One-side dewatering saves transportation costs, and the purified water can be reused for operations. Also, nutrients can be recycled. Let's now turn to the current situation. We have tested various biomasses using different batch reactors, starting from a 1 liter, then 2 liter, and up to 40 liter batches. We have now progressed to our continuous reactor prototype, which is over 80 liters in size. And however, a fully continuous HTC facility has been developed and is currently planned and being implemented for a regional wastewater treatment plant. We aim to make the HTC technology mobile, which is why we focused on a container-based design. Inside this box, there's a piping system, a feed unit, a discharge unit, cold separator, automatic degassing unit, and any further invention. The entire unit can be modularly expanded. When larger quantities need to be carbonized, another container with a piping system can simply be added. Water treatment will be handled by a separate container. As I mentioned at the beginning, we work closely with the company Steamergy. I would like to briefly introduce Steamergy technology. The Steamergy technology comprises two core innovations: the steam generator, which also serves as a heat storage system using liquid salt technology, and the steam engine, which combines the robustness of a classic steam engine with the efficiency of a diesel engine. A significant advantage of this technology is the versatility of the raw materials. Steam can be generated from both wind and solar energy, as well as through the combustion of landscape maintenance wood or CO2 neutral HTC biochar. Combustion produces hot gases, which are directed into the steam generator. It consists of salt, and the heat from the hot gases melts the salt. The liquids hot salt storage the thermal energy. And the hot salt then transfers the heat to water, creating steam. The steam drives the steam engine, which in turn powers a generator. By utilizing intermediate storage, energy can be assessed on demand, allowing for the use of whatever resources are currently available. And we believe that along with the Steamergy technology, the biochar from the HTC process can be used effectively, offering customers a complete solution that goes from handling liquid waste to providing energy. We conduct feasibility studies for the optimal utilization of wet and liquid biomasses into electricity, heat, and fertilizers. We develop facility concepts for decentralized drying and utilization of sewage sludge. Additionally, we perform hydrothermal carbonization with various biomasses while characterizing the material flows and products. Our laboratory analysis includes assessing product yields, determining calorific values, and evaluating parameters like dry matter, organic carbon, ash content, phosphorus, nitrogen, chemical and biological oxygen demand, as well as metal content. Thank you. Unfortunately, I'm unable to stay for the discussion round. If you have any questions or are interested in further discussion, please feel free to contact me at this email address. I will be happy to answer your questions and thank you for your understanding and have a nice day.